Hey guys, happy Tuesday! Welcome to Science. We're going to start a new chapter about weather this week, and we'll begin the chapter by learning a little bit about our atmosphere, about the layers of the atmosphere, all that good stuff. Let's go ahead and read first. So get your textbook pages 114 through 117 ready. If you'd rather read alone, that's totally fine. Just as we read, try your best to underline phrases or words that you think are important or interesting. Let's get started. There are many parts of weather other than storms. These parts are important as well. God has given people the ability to observe weather and learn about it. The weather that we observe takes place in a protective layer of air that surrounds the earth, atmosphere. In the beginning, God created an atmosphere, which is a thin blanket of gases to surround the earth. If the earth were the size of an apple, the atmosphere would be similar to the apple's skin. The atmosphere is very different to life on Earth, though. It lets in the right amount of energy from the sun and provides the air that we breathe. Pretty important. It also prevents extreme weather differences on the Earth. Contents of the atmosphere. One part of the atmosphere is air. But what's air? Air is a mixture of nitrogen, oxygen, carbon dioxide, and other gases in the atmosphere. We cannot see or feel these gases. God provided the kinds and amounts of atmospheric gases to support the kinds of life He created. Plants need the nitrogen and carbon dioxide to produce food. People and animals need oxygen to survive. Providing an atmosphere with this blend of gases is one way God meets the needs of living things. Another part of the atmosphere is dust particles. When you clean your bedroom, you probably stir up dust. Dust particles may seem annoying when you're cleaning. However, they're useful in the atmosphere. Dust helps water droplets and ice crystals in the clouds form rain, snow, and other types of precipitation. So here we got a diagram that breaks down the content of the atmosphere. So we got nitrogen, which is most of it. We also got oxygen and other gases. Air pressure. Gravity pulls the atmosphere close to the surface of the earth. At any moment, there are thousands of pounds of air pressing on you. The weight of the air is called air pressure. Near the surface of the earth, the atmosphere presses down on each square inch with 14.7 pounds of weight. Doesn't seem that air would weigh very much, but there's a huge amount of air above the earth. As the air is pulled toward the earth by gravity, it increases the pressure. Air pressure is greatest at the surface of the earth and decreases as you move away from the surface of the earth or gain altitude. Altitude is the measurement of the distance above sea level. The altitude affects air pressure. There's less air pressure on a high mountain than at the seashore. However, altitude is not the only factor that affects air pressure. Other factors, such as changes in temperatures, also affect air pressure. So as altitude increases, air pressure decreases. So the higher you go up a mountain, the less air pressure there is. One of the tools that Isaac Klein used at his weather station was a barometer. A barometer is an instrument used to measure air pressure. Knowing the air pressure is important when forecasting the weather. Changes in air pressure may mean that a storm is coming. Pilots are also alert to changes in air pressure because the changes can affect flying conditions. That's what a barometer looks like. Layers of the atmosphere. God designed the atmosphere to have several layers. Each layer is different. Together, though, these layers protect the earth and give it a controlled climate. The troposphere is the layer of the atmosphere that's closest to the earth. So it should be around here. Yep. But even the tallest mountain on the earth, Mount Everest, reaches only part way into the troposphere. About half of the air in the atmosphere is in the troposphere. The troposphere is also where weather occurs. The air in the troposphere holds in the radiant heat from the sun. This helps keep the surface of the earth warm. At higher altitudes, the air in the troposphere gets thinner and colder. Just as a thin sweater cannot keep you as warm as a thick coat can, the thinner air at higher altitudes cannot hold as much thermal energy as the denser air near the surface can. So that's why when we go up to high mountains, you might have felt that it gets colder, right? Weather is the condition of the atmosphere at any moment in time. The troposphere contains many particles and water droplets that affect the weather. The particles reflect light, allowing us to see colorful sunrises and sunsets. Next, the stratosphere is the next layer above the troposphere, right here. The air in the stratosphere continues to get thinner as you travel away from the surface of the Earth. Unlike the troposphere, the stratosphere increases in temperature as the altitude increases. So as you get higher, it gets warmer. God made the stratosphere to protect the Earth. During the day, the stratosphere shields the Earth from the harmful effects of the sun. At night, the stratosphere helps hold in some of the heat that the sun provided during the day. The ozone layer is in the upper part of the stratosphere. Ozone is a form of oxygen. Molecules of ozone have 3 atoms instead of 2 as in normal oxygen. The layer of this gas is one way the stratosphere protects the surface of the Earth from the sun's harmful rays. This is the ozone layer. The higher layers of the atmosphere also help protect the Earth. Meteors heading toward the Earth burn up in the mesosphere. Nice. So protect us from the meteors. These burning meteors are the shooting stars we sometimes see. Many of our weather and communication satellites are in the thermosphere. The exosphere is the layer of the Earth farthest from the sun, and this layer gradually fades into space. Exosphere. Some people compare the atmosphere to a greenhouse. A greenhouse is a special building often made of glass. It completely surrounds and protects the plants inside from extreme heat or cold. The sunlight, temperature, and moisture inside a greenhouse are carefully adjusted to provide the ideal environment for the plants. In a similar way, God designed the atmosphere to completely surround the Earth. He planned for the atmosphere to protect the Earth and provide the proper weather needed for each area of the Earth. Okay, I know this was a lot of information to digest. So we're going to break these concepts down into major points. So first of all, atmosphere. Here's a picture. It's a thin blanket of gases to surround the Earth. Do you remember what kind of gases make up the atmosphere? Yep, you got it. We got nitrogen, oxygen, some other gases, carbon dioxide, even dust particles that help create precipitation like rain. And that's what the atmosphere is made of. And why is the atmosphere important? What is its job? So you might have said that it lets in energy from the sun, it protects the Earth from extreme weather differences. And why do we have a picture of an Earth that looks like an apple? What did the book say about, how did the book compare the atmosphere of the Earth to an apple? Yeah, very good. So the atmosphere is similar to the apple's skin. It's the outermost layer, right? That was atmosphere. The second concept the book talked about is air pressure, which is basically how much the air weighs. Did you know that air actually weighs? Sure you did. So what happens is that gravity pulls the atmosphere close to the Earth, as we know. And believe it or not, right now there are thousands of kilograms of air pressing on you right now. Can you feel the ton of air? I can't, but it's there. So more about air pressure. You might have noticed, like when you're in a plane, of course, the air pressure changes as you go up in the sky, so your ears might feel blocked, right? That's a good example of that. So the book says that air pressure is the greatest at the surface of the Earth, so that's basically like the ground. So it's the greatest on the ground, and then it gets smaller as you move higher. That's why when we go up in the plane, you can feel the difference in air pressure. So quick vocab interruption. Altitude is, well, you gain altitude as you go higher up from the surface of the earth. So you can see as you go up higher into the mountain, you are at a higher altitude, okay? In other words, it's just a measurement of the distance above the sea level, above the ground level. Why is this important? Because altitude, or how high you are, the altitude affects air pressure, just like we talked about the plane example. So a high mountain, you have less air pressure, and there's more air pressure if you're on the seashore or on the ground. The book also talks about barometers. Barometers are instruments that measure air pressure, okay? And it's important because it helps us predict the weather. It helps meteorologists determine if there's going to be a storm coming. It's also important to pilots. Do you remember why? Yeah, for sure, because air pressure changes can affect flying conditions. So pilots need to be very alert about the changes in air pressure as well. Even in the plane, sometimes they make announcements about it. Then we read a bit about the layers of the atmosphere. So we have a nice diagram here that illustrates the atmosphere. Troposphere being the one closest to the Earth, exosphere being the furthest away. They do a lot of different things. They protect us from the sun's rays. It affects the weather, shields us from the sun, like I mentioned. And yeah. And the book also compares the atmosphere to a greenhouse, because in the same way that a greenhouse protects all the living things inside it, our atmosphere protects all the living things inside Earth. Guys, go ahead and watch this video. It'll be in the playlist as well as in the description box and in Google Classroom. It does a really good job breaking down the layers of the atmosphere. And then I'll make a part 2 video going over the answers not all the answers, but some of the answers and all the directions in the workbook page we're going to do. So I'll talk to you in a few seconds. Bye!